The concept of an ever-expanding universe has been a central pillar in our understanding of cosmology for nearly a century. Since Edwin Hubble's groundbreaking discovery in 1929 that distant galaxies are moving away from us, scientists have largely agreed that the universe is expanding. This expansion, driven by mysterious forces like dark energy, seemed to be an unstoppable process, suggesting that the cosmos would continue to stretch out indefinitely. However, recent observations by the James Webb Space Telescope, JWST, have thrown the scientific community into turmoil, sparking speculation that the universe may have halted its expansion. Could the cosmos really be static once again? Is our understanding of space, time, and the fate of the universe flawed? The possibility that the universe has stopped expanding, or at the very least has significantly slowed down, would have profound implications for our understanding of the cosmos. The implications of such a revelation are vast and complex, and the scientific world is grappling with this startling new information. Before we dive into the potential ramifications of a static universe, it is important to revisit some fundamental concepts. The idea that the universe is expanding came to light when Edwin Hubble observed that distant galaxies were redshifted, meaning they appeared to be moving away from us. This discovery led to the formulation of the Big Bang theory, which postulates that the universe began as a singular point approximately 13.8 billion years ago and has been expanding ever since. For decades, scientists believed that this expansion was slowing down due to gravitational forces. However, in the late 1990s, two independent teams of astronomers made an extraordinary discovery. The expansion of the universe was not slowing down but actually accelerating. This was attributed to a mysterious force known as dark energy, which makes up about 68% of the universe. Dark energy seemed to be propelling galaxies apart at an ever-increasing rate. This understanding of an accelerating universe has been the prevailing model for over 20 years. But the recent observations from the James Webb Space Telescope suggest something completely unexpected, something that could turn our understanding of cosmology on its head. Launched on December 25, 2021, the James Webb Space Telescope has been hailed as one of the most ambitious space missions ever undertaken. As the successor to the Hubble Space Telescope, JWST was designed to peer deeper into space and further back in time than any previous observatory, offering unprecedented clarity of the universe's earliest stars and galaxies. Its revolutionary infrared technology allows it to detect celestial objects that are too faint or too distant for other telescopes to observe. Since it began sending back data in mid-2022, JWST has already made several groundbreaking discoveries. It has observed the first galaxies formed just a few hundred million years after the Big Bang, studied exoplanets with atmospheres potentially capable of supporting life, and revealed astonishing details about the structures of distant star systems. But its latest observations have left scientists shocked. Data from JWST may suggest that the universe's expansion is slowing down or has even halted altogether. This revelation, if confirmed, could challenge the very foundations of modern cosmology. The speculation that the universe may no longer be expanding comes from a series of high-precision measurements made by JWST. Specifically, the telescope has been observing distant galaxies and their redshifts, essentially the light they emit as they move away from us. What the scientists were looking for was confirmation of the standard model of cosmology, which predicts that these galaxies should show a redshift consistent with an accelerating expansion of the universe. However, what they found was not what they expected. Preliminary analysis of JWST's data suggests that some distant galaxies are not moving away from us as quickly as the current model would predict. In fact, some galaxies appear to show little to no redshift at all. This has raised the alarming possibility that the universe may no longer be expanding, or that the rate of expansion has dramatically decreased. Such a finding could mean that the influence of dark energy is diminishing or that some previously unknown factor is altering the expansion of spacetime itself. More data and analysis are needed to confirm these results, but the initial findings have already sparked intense debate within the scientific community. If the universe has indeed stopped expanding, it could signify a major shift in our understanding of dark energy. For years, dark energy has been thought to be the driving force behind the universe's accelerated expansion, but JWST's findings may suggest that this mysterious force is not as constant as previously believed. One possible explanation is that dark energy is weakening or even disappearing. If this is the case, it would mean that the universe is entering a new phase, one where the expansion is no longer driven by dark energy. This could have enormous implications for the fate of the universe. Cosmologists have long speculated about the ultimate destiny of the cosmos. One scenario, known as the Big Freeze, suggests that the universe will continue to expand indefinitely, becoming colder and more diffuse over time. Another scenario, the Big Rip, proposes that the expansion will accelerate to the point where galaxies, stars, and even atoms are torn apart. But if the universe has stopped expanding, or if its expansion is slowing down, we may be heading toward a different outcome altogether. One possibility is a big crunch, where the universe's expansion reverses, and everything begins to collapse back in on itself, eventually returning to a singular point. Another, less extreme outcome could be a steady-state universe, where expansion halts, and the cosmos reaches a kind of equilibrium. New theories and models. The potential halt in the universe's expansion has already prompted several new theories and models. One idea is that dark energy is not a constant force, but rather a dynamic one that changes over time. If dark energy is losing strength, it could explain the apparent slowing of the universe's expansion. Another theory suggests that our understanding of gravity at cosmic scales may be incomplete. Perhaps there is some previously unknown interaction between matter and space-time that is influencing the universe's behavior in ways we have yet to fully grasp. There are also more radical ideas being floated. Some physicists speculate that we may be living in a multiverse, and that our universe is just one of many. In this scenario, the behavior of our universe may be influenced by neighboring universes with different physical properties. While this idea is highly speculative, it underscores the deep uncertainties surrounding the nature of the cosmos. The scientific community reacts. The reaction to JWST's findings has been a mix of excitement, skepticism, and cautious optimism. Many scientists are urging patience, pointing out that the data is still preliminary and that further analysis is needed before any definitive conclusions can be drawn. Others are already exploring new theoretical frameworks to explain the findings. Some researchers are quick to point out that cosmology has faced major paradigm shifts before. The discovery of dark energy itself was a huge shock to the scientific community, forcing astronomers to revise their understanding of the universe. If JWST's data does indeed point to a halt in cosmic expansion, it would represent yet another major revolution in our understanding of the universe. Astrophysicist Katie Mack, for example, has noted that if the expansion has slowed, it could signal that we are entering an entirely new era of cosmic history. It would be a massive change in how we think about the evolution of the universe, she said in a recent interview. It's not just a small tweak to the model. It's a complete overhaul. While the possibility that the universe has stopped expanding is thrilling, scientists are cautious about jumping to conclusions. More data is needed to confirm JWST's findings, and the scientific community will be working diligently to either corroborate or refute these initial observations. In the coming years, JWST will continue to gather data from the farthest reaches of the universe, and other observatories, both ground-based and space-based, will work to provide additional insights. Scientists will also be developing new theoretical models to explain what we are seeing and to better understand the role of dark energy, gravity, and other cosmic forces in shaping the universe. If the findings hold, it could represent one of the most significant discoveries in the history of cosmology, reshaping our understanding of the universe and our place within it. In the meantime, the world waits with bated breath for the next revelation from the James Webb Space Telescope, knowing that each new discovery has the potential to change everything we thought we knew about the cosmos.